Okay. But I am still working on a similar topic. So my dissertation was about robotic bees and about bees more generally, actually. And so I am still thinking a lot about bees. I'm an assistant professor at Pratt Institute now, and having done my PhD at IU, it is really nice to have the ACI conference there. Even though we can't be in person, I wish that we could. But kind of being there in spirit, it is nice to be back in that space. So interestingly, based on kind of our last conversation, I was thinking a lot about my work, which is not a direct interaction. But I think a lot of the questions that were brought up in the previous session might be relevant, maybe in a slightly different way in this kind of technology, which is more like sensing technology and kind of monitoring technology. So I started doing work on bees, if I could, so there we go. So I started doing work on bees. Oh, sorry, I'm having a little issue with my computer here. Here we go, okay. So this is an article from The Guardian from a few years back. And so I think a lot about extinction. I think many of us probably think about this a lot. And I started kind of thinking a lot about insects, partly because they're ignored a lot when we talk about biodiversity and extinction. And we tend to see charismatic species quite often. You know, we think about pandas and elephants and things like that. And a lot of the work in this conference I was thinking about actually focuses on a lot of animals I think a lot of us are familiar with, like dogs. And but insects are one of those things that we often don't think about, or we only think about them if they're sort of a problem, you know, if we have them in our house or something. But insects are doing all this really incredibly important work. And bees are doing all of this really incredibly important work. And bees have actually become almost sort of a charismatic species. We've definitely seen a lot of interest in bees, I think, over the past few years, except that it's actually honeybees that tend to dominate the conversation. So when I was doing my dissertation research, you know, the vast majority of research that I found was about honeybees in particular, which in some ways makes sense because these are domesticated animals. They're used in commercial processes. So when we think about not only honey production, but pollination itself. So, you know, 80% of the bees in this country get trucked across the country to California to pollinate the almonds. So honeybees kind of became this really dominant thing in the discourse. And I noticed this a lot kind of doing research. And a lot of my dissertation research was actually about honeybees, partly because I ended up talking to a lot of beekeepers and a lot of farmers and things like that. And so maybe not surprisingly, a lot of the technology for bees or around bees is specifically about honeybees. So kind of thinking about what are maybe called smart hives. There's a whole assortment of kind of things like this that have emerged just in the past few years, past 5 years maybe, to kind of track and monitor honeybees, to kind of see what's going on with them, especially because of this kind of crisis with bees dying. And there's many reasons for that, although we don't know exactly the cause, but pesticides, climate crisis, you know, habitat loss, parasites, there's actually a whole assortment of things that are really harming the bees. And so I spent a lot of time kind of looking at all these different technologies just to kind of see what was out there. There's a lot of sensing technologies that can be part of a beehive to kind of get a sense of maybe what's going on in there. And so you can see here, this is maybe the kinds of things you might see from a sensor. So if you could maybe know if your queen has died, for example, could be a really important piece of information to know if there's a disease in one of your hives. To know if there was a sudden change in temperature, something that could maybe really harm the bees. And so again, a lot of these technologies are really, you can see them as something that might be useful in a larger kind of commercial practice, you know, agricultural practice. If you have dozens or hundreds of beehives, you can't necessarily check on them every day. And you also don't necessarily want to disturb the bees by checking on them all the time. And so this is maybe a way of helping a beekeeper to kind of know what's going on with their particular hives. This is also, wanted to mention the B Corp because this is a Bloomington startup that I worked with a bit during my dissertation. And this is another technology called Verifly, which is like an infrared scanning technology. So you can sort of scan your beehive to see how many bees are in there. And this is because bees are actually, when you use bees for pollination, they are sold by the number of bees that are in the actual hive. So having kind of that sense of how many. So you can kind of see how a lot of these are really geared towards commercial pollination kind of processes, which is probably because that's where all the money is. But it definitely came up a lot here. Here's one last one called the Varroa gate, which kind of protects against this particular parasite. So bees will kind of go through this little entrance to potentially kind of protect the rest of the hive. So after spending a lot of time on honeybees and being away from my dissertation for a little bit of time, I actually really started to think about this question: what about solitary bees, which are actually the majority of pollinators and doing all sorts of work in our ecosystems, and are bees that we kind of sometimes don't think about or sometimes don't see because honeybees get so much notoriety. I also do a lot of work in urban space. So I live in New York City. And so I think a lot about animals in urban space. And we have lots and lots of solitary bees here. We have lots of urban beekeepers too, but certainly lots of solitary bees. So the early part of this research was actually kind of looking at the bees of New York City, basically, and thinking through a lot of the different species here and what kind of species I might want to design something for. So I landed on mason bees, partly because mason bees are a general pollinator. They're very gentle, they don't sting, and also because mason bee houses have become sort of popular. So there's a good chance you may have seen a mason bee house somewhere in your neighborhood or something. I've definitely seen these around Brooklyn, kind of popping up here and there. And so these were materials that were also just really accessible and available, which was important to me for this project because I wanted this to be something that was a project that would maybe lead to the kinds of things that anyone could do. So just anyone who was interested in building a mason bee house could do that. And these kinds of kits and supplies and stuff are really available everywhere. So mason bees live in these little tubes, little cardboard tubes, and they can be any sorts of material, bamboo. They're often made out of wood, sort of different size holes. So mason bees will take mud and water and kind of build little structures in there. That's why they're called mason bees. They do sort of masonry inside these little tubes. And so the first part of this was actually just kind of playing with some different structures, knowing that I wanted to build some mason bee houses, but playing with different kind of forms, different materials. Some of the challenges, and I'll talk about this a little bit more at the end of my talk too, were sort of running into unsustainable materials. So thinking about building something that's going to be outside, it may need to be protected with plastic. I used glass in some of my designs, which is something that's breakable. So a lot of thinking about sort of designing to put something out on your balcony or in your yard brings up some of these issues with different materials. And then some of the forms just didn't work. So like everyone kind of knows, iteration is really part of this process. So a lot of the beginning part was actually just trying out different forms and seeing, where things might kind of fit. And the thing that really dictated a lot of the form and the structure was this, which was kind of my guiding question, which was, can we integrate sensing technology into mason bee houses to give us kind of insight into bee habitats? And so this is one of the forms I was working on. I used just a little Arduino board with some kind of basic sensors to kind of think through how we might use sensing tools and technology. I originally thought these might actually be part of the tubes themselves, which ended up being not a great idea. And I was sort of worried this could be harmful to the bees, or it might be disruptive to their environment. So then it became more about maybe capturing data around that space. And maybe even just more broadly climate data that might be used for other purposes. So this is one of the final designs that I did, which has moisture, temperature, and humidity sensors. There's a little bee stamp on it as well. So I was thinking a lot about if this was out in a space, someone might not know what it was, and maybe that would give you some insight into what this piece was kind of doing. And then the tops of these tubes were painted. So a lot of this project too was actually kind of playing with some different types of design to think through the ways bees might interact with a piece like this. And so bees, respond to color. And with mason bees, one of the things that I kind of discovered in research was that it can be really helpful to have holes that are different sizes or different shapes, partly because it can be confusing if it's totally uniform to actually find your home. So you could think of these colors as kind of like addresses for the bees to actually find their tube that they want to go to. And so this is something, this is very much a work in progress as well. So I have other kind of things I'm thinking about doing with these pieces. So I'm also happy to hear ideas for kind of future plans here, because one of the things to figure out is this confusing to the bees or is it helpful? You know, we don't know yet how they would react to this, or if it would feel like it was a flower and then they got confused. So there's lots of things I've kind of been thinking about kind of trying out with these. And then this one here has a kind of a case that covers it to protect it from the rain and to protect the battery and that kind of thing. This is another final piece, which is more of kind of a modular piece. And so this one was actually sort of playing with trying out kind of different styles. This is something you could kind of build on and expand upon as well. This one also has a sensor, still a circuit playground sensor for the plant. So it's actually kind of thinking maybe more about plant well-being. And I was thinking a lot about kind of multi-species support in these pieces, and that these are designs that need to be placed. Bees need to be near a source of food, so they need to be near plants and near flowers. They also need to have a water source. So there's actually water right here on the bottom left. And so thinking about the kinds of things that we might need to sort of provide in that space versus, you know, which things are actually going to be part of the environment, because plants presumably, of course, should be part of the environment as well. So does it need to be part of the bee house, or, you know, how close does it kind of need to be to the bees? So this is another version. So as I was kind of working on this project, I ended up, by the end of this, and meanwhile, this whole project was done during COVID while I was basically stuck in my apartment in Brooklyn by myself. And so I was just kind of, this project kind of took over my kitchen table for a while. And I started thinking a lot about the role of digital technology in a design like this. And so I think in being an HCI, you know, of course, we have this tendency to want to digitize everything or bring digital technology into every design. And that was kind of my initial thinking around this. And by the time I actually got done with these designs, I actually really began to question that goal and whether or not sensors and sensing technologies were even necessary for a design like this. And part of that really had to do with that question of sustainability, because, you know, the Mason bee house, the analog non-digital version, is made with non-toxic materials, made with wood and bamboo and, you know, cardboard and things like that. So it felt like something that you could certainly place in a garden. Whereas when you start using sensing components, you start using plastic, things that are cheap and disposable, a battery, you know, all these things felt actually really inherently unsustainable to me. And so there was this kind of tension with trying to integrate that into something that was designed to support bees and support, you know, ecological system. And so by the end of this project, I really started to think about maybe we should be developing ways of thinking about when we should not intervene. You know, when is actually the design already working in and of itself, and we don't necessarily need to know all of those kind of climate metrics. And so I think one thing I've been thinking a lot about is if this project might belong to a larger project, thinking about something like citizen science, maybe if everybody was collecting data in their yards, that could lead to a larger kind of climate data project, which I could see a lot of value in that. I think education as well. I sort of thought, you know, this is a great project for kids to maybe learn about biodiversity, learn about bees, and also learn about STEM technology and learn about computing technology at the same time. So I certainly didn't think it was necessarily all bad. But I sort of began to question, is this the best way we can help bees? You know, is this the best way we can actually learn about their environments? And oftentimes, you know, in my research and thinking about my own work with bees and the beekeepers that I know and people I work with bees and all animals, I've noticed this a lot in a lot of the presentations actually, is that a lot of the things about animals that we interact with, we can actually gather a lot of those things intuitively. I think many people kind of know certain things about, you know, whether or not the bees seem to be happy in their yard or not, you know, just by spending time in the yard and having some awareness of that. And then the last thing here I'll just mention is this idea of an evocative object. So these pieces have been displayed in like gallery contexts over the past year at Pratt and kind of around Brooklyn. And one of the things I notice is people really respond to the visual design of them and then seem to take an interest in solitary bees in a way that maybe they didn't before. And so to me, that actually strikes me as something useful to maybe challenge people to think about species that they wouldn't normally think about, or to think about a different type of bees rather than honeybees. just based on kind of the form being sort of interesting or exciting. At the same time, I do want this to be a functional object. So I didn't want it to be purely a gallery object. I did want it to do more than that. But it left me feeling like maybe that is one thing that kind of came out of this that might be a useful thing. So these are kind of in progress. We have a garden on campus and also a community garden that I'm part of. And I'm going to put these actually in the garden, not until a little bit warmer weather now that we're heading into winter, but in the spring. And I would actually kind of like to do a little bit of a comparison to think through, like, what are the kinds of things we get from this and what are the benefits of it? Does it help us to maybe place it in a way that's going to be more helpful for bees? You kind of knowing some of those metrics around, say, temperature or something like that. Or can we have a regular analog mason bee house that is doing the job just fine? So kind of seeing what the differences are there. And then maybe just kind of thinking through how this could maybe be part of a larger kind of climate project that helps us kind of think about bees in relation to kind of other elements in the ecosystem. So those are the bee houses that I've been working on for the past bit here. So just wanted to share that, and I'm happy to have any questions or thoughts that you may